Assalamualaikum warahmatullahi wabarakatuh. This video is for ECM 366. In this video, we are going to cover topic 3, taking of quantities for building and civil engineering works. And for this video, we are going to focus on slab. So here are the course outcome, program outcome, and also the lesson outcome. Straight away, we move to the question or exercise for this topic. So the question is, figure 1 shows the second floor plan of a building. By using the data given below, prepare a taking off sheet for concrete work and reinforcement bar for slab AB13 only. So here is the question provide the details for the thickness of the slab, cover concrete, density of steel, reinforcement of X direction, which is R8, and the spacing is 175 mm, and also it provided with the reinforcement for Y direction. It used R12 and the spacing is 200, and also there is a price for R8, R12, price for the concrete, and also provided the column size C1, which is 200 times 200, and there is also size for column C2, which is 250 times 200. So the slab AB13 is referring to this area AB and 13, so it is for dining area. First, we look at the solution provided in this slide. So for the first one, concrete work. So basically, for the thickness, it already provided in the question, whereby the thickness is 225 mm. So in order for you to get the volume of concrete, you need to know the area of your slab. Based on this diagram, you need to determine the area here, and then you need to multiply with the thickness just now. So after that, you will get the volume of the concrete. So provided the length here is 4200 mm, and then you need to minus with this half beam. It is provided the half beam is 200. The full beam, it will be 200. So for half beam, it will be 100 mm. And then for this full beam, it will be 250. So for half beam, it will be 125 mm. So for this length, it will be 4200 minus with the half beam here 100, and minus with the half beam here, which is 125. So we'll get the length here. After that, you need to determine the length for this side. So given that the length here is 3500, okay, so you need to minus with half beam here, so it will be 100, because the full beam, it will be 200, and the same thing here, you need to minus with half beam, which is 100, because the full beam, it will be 200. Right, so for this one, 3500 minus with 100 minus with 100, so you get the length of this side. After you determine the length, you need to multiply the L here. Let's say this is L1, this one is L2, so you multiply L1, L2 and multiply with the thickness of the slab just now, so you will get the volume of the concrete. So we look at the answer here, right? So for the first one, 4.2 minus with half beam minus with another half beam, you will get 3.975. so you put it at the dimension column. And for another side is 3.5 minus with two half beam, because the size of beam is similar, so you will get 3.3. so you put it here. And this one is basically the depth or the thickness of your slab, so you multiply, you will get 2.95 meter cube of concrete. So this is for the slab. Next, we move for the reinforcement for the slab. So basically we have X direction and Y direction. So how to determine whether it is X direction or Y direction? Basically, X direction is for the longest reinforcement, and for the Y direction it is for the shortest reinforcement. Right, so student need to remember this. X direction meaning that your reinforcement is long, Y is for meaning that your reinforcement is short. If you look at this diagram, so your reinforcement will be in this direction, and another one it will be on another direction, another one it will be at this direction. So here I can say that the blue reinforcement, it will be the Y direction, and for the brown reinforcement it will be the X direction. How do I know? Because based on the diagram that we have here, this side of line it will be 4,200. So meaning that this reinforcement it will be longer than the blue reinforcement, because for the blue the length is only 3,500. So from that dimension I know which one is X direction of reinforcement, which one is Y direction of reinforcement. Okay, first we solve for the X direction first. So your reinforcement for X direction it will be at this direction, and then remember it will have a bend at both of the end. Right, so first we are going to determine the length of one reinforcement here. So now you have 4,200 mm, but basically just up to this half beam and half beam here. So if you look at this diagram, your reinforcement is more than 4,200, and if you notice here it will be the cover, here it will be the cover, so meaning that it has two cover. So the length to get that equal to 4,200, you need to plus with half column. So the half column here it will be 100, and plus another half column at another side here, so it will be 125. So you need to minus with two cover, so the cover will be 25, so two cover it will be 50, and then you need to plus with two bends, because you have one here and another one at another end. So the bend it will be 2, bend will be 5D, so 5D is equal to, you use R8 for the reinforcement, so 0.08. I know it is R8 because I'm referring to the question on the details that provided. So for X direction it use R8. After you get the total length for the one reinforcement for X direction, next you need to determine the number of reinforcement for the X direction of the bar. So you know that your bar will be here, okay, and provided spacing for the X direction is 175. The spacing here is 175. The length that need the bar is this one, so it will be 3500 minus with 2 half column, because you have half column here and another half column here, so minus 200, so it will be 3300. So to determine number of reinforcement or number of bar equal to the length that you have is 3300 divided by spacing 175, and you need to plus 1, so you will get the number of reinforcement or number of the bar. So we refer to the solution provided for X direction. First, it calculate the length of one reinforcement bar for X direction. So it gets 4.455, and then we put it at the dimension column, and after that the solution calculate for the number of bar for X direction. So it gets 19.86, and we round up and it become 20, so we put it at the times sign. So you multiply, you will get 89.1 meter of R8. So that is the answer for the X direction. Next, for Y direction, it will be the same process or the same step. So for Y direction, your bar will be at this direction, and the same thing, your bar will have two bands. So now you are going to determine the length of one bar for Y direction, and here it will be the cover, right? So meaning that you have length, so it is 3500, so you plus with 2 half beam or 2 half column, so it will be 100 and 100 here, so plus 200 minus with 2 cover, it will be 50 for 2 cover, and plus with 2 bend, so 2 times 5. So the diameter for Y direction of reinforcement provided in the question, it is 12, so 0.012. so after you calculate, you will get the total length for one reinforcement for Y direction. Next, you need to determine number of reinforcement or number of bar for Y direction. So your bar will be here, and you need to refer to the, so provided that the spacing for X direction is 200, then so the spacing here, it will be 200, and you need to calculate the length that required the reinforcement. So it will be 4200 minus with half column here, it will be 100, and minus with half column here, it will be 125. So after you get this length, you divide with the spacing 200 and you plus 1, so you will get the number of bar. So we look at the answer provided for the y direction. Right, so first for the length 3.5 minus with 2 half beam and minus with 2 cover plus with 2 bend, so you will get 3.77. so the value you put inside of the dimension, and then you need to calculate the number of bar. So you will get the length required bar is 3.975, and then you divide by the spacing plus 1, you will get 20.9, and you must round up, it will be 21. So 21 you put inside of the times sign, so you multiply, you will get 79.17 meter of reinforcement arc 12. Thank you very much.